So today we are going to finish up our prerequisite chapter. We're going to do the last part of section 5. And today it's going to be rational expressions with a complex fraction. So in other words, fractions and fractions. So there are two options that you can choose to solve these complex fractions. I am going to show you how to do option 2. Option 1 would be to find the LCD of each fraction, multiply each term of that LCD, and then simplify. But I'm going to teach you to find the LCD of the numerator and the LCD of the denominator separately, combine them, and then state, change, flip. So that's what we're going to do. So let's go ahead and take a look at our first example. So the first one has two fractions here, two fractions. So we have, this is the main fraction bar right here. So that fraction bar means division. So really all we're doing here is the top fraction, 1 over x, divided by the denominator, let me do that in another color, divided by 1 over x squared. So what I'm going to do is keep, change, flip, keep this one the same, change this to multiplication, and flip the second fraction upside down. Now we have what we did in P5B, a multiplication problem. And I can simplify the x's, take that x away, it becomes a 1, take the exponent away, and now it's just 1 times x left in the top and 1 times 1 in the bottom. So my final answer is just x. Still not too bad. This is my main fraction bar here. So again, I'm doing 1 over x minus 2 divided by 1 over x squared minus 4. So here again is that division. So the P5B, keep, change, flip it, keep this one the same, change it to multiplication, flip it upside down. Now remember, in order to multiply here, I have to factor first because I got to look for things to cancel. So I'm going to factor this numerator. This is the difference of two squares. It becomes x plus 2, x minus 2, and it's over 1. And then multiply. And like he said, this will cancel the x minus 2's. And then you're left with x plus 2 over 1. Anytime you have a 1 in the denominator, it's just x plus 2. Here the final answer is just x plus 2, because anything divided by 1 is itself. Next one, still the same simple process. We're going to factor the difference of two squares. For number 3, again, we've got a fraction and a fraction. The main fraction bar separating them is the division. Okay, so for the numerator, we have 1 over x squared minus 9 divided by the denominator, which was 1 over x minus 3. Keep, flip, change it. So keep it, change it to multiplication, flip upside down. And now we need to factor that difference of two squares. So the yellow one becomes x plus 3, x minus 3. The white one, nothing to factor there. So it just stays x minus 3 over 1. Look for things to simplify. This will become a 1. Anything divided by itself is 1. So then my final answer is just 1 over x plus 3. And you're done. All right, so for number 4, what we're going to do is we need to subtract the numerator, get our answer, subtract the denominator, get our answer, and then just do keep, change, flip. Turn it into a division problem. So what I'm going to do here is I could add a 1 underneath this 3, and my common denominator is going to be x. So this fraction here is missing the x, so I have to times the top and the bottom by it. So then now this fraction will become 2 over x minus 3x over x. We're going to add our subtract our numerators. So this becomes 2 minus 3x over x. That is the simplified numerator. Now I have to do the same thing to the denominator. I could put a 1 under here. My common denominator is going to be x minus 1. So I'm going to multiply this fraction by x minus 1. So now this becomes x minus 1 over x minus 1 minus 1 over x minus 1. Now I need to add my numerator or subtract my numerator, and it becomes x minus 2 over x minus 1. Now I can do the keep, change, flip. So really what my problem is, it's going to be the yellow divided by the white. Keep, change, flip it. The white gets flipped. So make this x minus 1 over x minus 2. The yellow stays the same. And now I'm going to look for things to simplify. However, remember all of this is attached and these are attached. So nothing simplifies here. Yeah. All right, so that denominator should not be a 3. It should be an x. Thank you. All right, so that's an x. Fix that better. All right, thank you. Good catch. All right, so this is an x. Now, nothing simplifies here because remember, the x minus 1 and the x minus 2 are attached. In order to get something to cancel, it needs to look identical. So my final answer here is going to be 2 minus 3x times x minus 1 over x times x minus 2. And you're done.
So this is the final answer?
Yes. Now, when you go to check your homework tonight, the homework answers that are there have it foiled. So they actually foil it and distribute it. However, on the test, you can leave it in factored form. Don't distribute it, don't factor it, or foil it. So for number 5, now the numerator, there's nothing to add or subtract. We're just leaving it like that, but we do need to simplify that denominator. So I could add a 1 underneath here, and notice my common denominator is going to be 5. So what I need to multiply this fraction by is 5 to the top and the bottom. So now my denominator becomes x squared over 5 minus 25 over 5. And then I still have the same thing in the top. And now what I can do is, this is a division problem now. So I have x plus 5, and I can put a 1 under it, divided by x squared minus 25 over 5. Because once I combine, it's got the common denominator. So now I'm going to do a keep, change, flip. So I keep the yellow, change it to multiplication, and I need to flip this fraction here, but I'm also going to factor the difference of squares. So I'm going to factor it into x plus 5 and x minus 5. So this right here became x plus 5, x minus 5. And then now I'm going to look for things to simplify. I can simplify the x plus 5, and now I'm going to multiply what's left over. So this all became 1s, so 1 times 5 is 5, and 1 times x minus 5 is just x minus 5. Do not do this. Do not do that. It's attached. So the final answer is 5 over x minus 5. Number 6. Nothing here to add or subtract and find a common denominator. So all I'm doing here, again, this is my division sign. So I'm going to do the top, which is x squared minus 1 over x, divided by x minus 1 squared over x. Now I need to factor the top of the yellow. That's going to factor into x plus 1, x minus 1. Then I'm going to change the division to multiplication. And then now I can flip this upside down. And what I can do here is I'm going to also make the binomial that's squared. I'm going to write it 2 times. Now I'm going to look for things to simplify. I can simplify the x minus 1, and I can simplify the x's. And now what remains is just x plus 1 over x minus 1. And again, these are attached, so do not try to cancel the x's and tell me the answer is -1. They are connected, and I can only simplify when it looks identical. This one I have to find a common denominator and simplify the numerator and the denominator before I do the keep, change, flip. So again, you can add a 1 underneath here. My common denominator here is going to be x, so I'm going to times the top and the bottom by x. So then this now becomes 6x over x minus 5 over x. I can add the numerator, and now that's my simplified numerator. Now I need to do the same thing to the denominator. I can add a 1 under this 1. And again, my common denominator is going to be x. So I'm going to multiply this by x and x. So then it becomes x over x plus 5 over x, which will simplify to x plus 5 over x. Now we had our fraction bar here. So now I need to do the keep, flip, change. I'm dividing the red by the blue. So I have 6x minus 5 over x divided by the blue. And again, I'm going to keep, flip, change the blue. So the red stays. Change the division to multiplication. Flip the blue upside down. And now I'm going to look for things to simplify. The only things that simplify here are going to be the x's. And then you're left with 6x minus 5 over x plus 5. Again, do not try to cancel the 5's. So for number 8, we need to find a common denominator. My common denominator is going to be both of these. It's actually going to be a times a plus 1. So the first fraction is missing the a. So I times the top and the bottom by it. So it becomes a squared. And then the second fraction is missing the a plus 1. Whatever you multiply to the bottom, multiply to the top. So 1 times a plus 1 is just a plus 1. And then the denominator now is the same. And now I can add my numerator. Do not try to cancel anything until after you combine your like terms. So a squared plus a plus 1 over a times a plus 1. Now I have to simplify the denominator. So now, again, what I'm missing here is a plus 1. And this one's missing the a. So for the first one, we're going to do a plus 1 times 1 is just a plus 1. And then it's got the common denominator now. And then plus, and then a times 1 is just a. And then over the common denominator. And now I need to combine my numerator. And then now what's underneath here is going to be 2a. 2a plus 1 over a times a plus 1. Now remember, this was the main fraction bar here, so this is my problem right here, and I do a keep, flip, change. I combine these like terms, it's 1a plus 1a, and that's how I get 2a. Okay, so now let's go ahead and do the keep, flip, change. So the yellow, a squared plus a plus 1 over a times a plus 1, and then divided by the blue, 2a plus 1 over a times a plus 1. Keep, change, flip. The blue's going to flip. And then the multiplication, the division goes to multiplication. And I'm going to write the yellow and black so it shows up better. So this one is going to stay the same, a squared plus a plus 1. That can't be factored. There aren't any factors of 1 that'll give me 1. So that's why I didn't factor that trinomial. Now I look for things to simplify. So the a's cancel. The a plus 1 cancels. And now the only thing that remains is that trinomial, a squared plus a plus 1 over 2a plus 1. Nothing simplifies here. This is all attached, and so is this. So for number 9, again, we need to simplify the numerator, simplify the denominator, and then do keep, flip, change. So I can add a 1 under the 2, if it helps you to see. So then my common denominator is going to be x. So I have to times that by x. So then this turns into 2x minus 2x divided by x minus 2 over x. So this turns into 2x minus 2 over x. Then I've got my fraction bar here. And then I'm going to divide that. And I got to find a common denominator. Again, it's going to be x. So 2x over x plus 2 over x. So this one turns into 2x plus 2 over x. So now I can keep, flip, change here. I'm going to do green divided by white. So 2x minus 2 over x divided by the white. And now I need to factor GCF out of those numerators, but let me go ahead and flip it. So the green stays the same. I'm going to factor GCF out of 2. And then the white flips. And then this becomes an x. And I'm going to factor GCF out of that one as well. And now I can look for things to simplify. So what's going to simplify here are the x's. So these become 1s. And then I can also simplify the 2's. They become 1s. And now I'm just left with x minus 1 over x plus 1. Again, do not try to cancel those x's. It is attached, so that is your final answer. And then one last problem. We only have to subtract the numerator. The denominator of this complex fraction is good. So let me just go ahead and find a common denominator of the numerator. My common denominator of the numerator is going to be x times x plus 3. And I'm subtracting here. So the first fraction is missing the x. And then this becomes 1 times x. That's just an x in the top. The bottom's missing the x plus 3. And 1 times, and actually I'm going to distribute this as a negative 1. So then this becomes negative x minus 3. Now I need to combine my like terms in the numerator. So x plus negative x is gone. So I'm just left with negative 3 over x times x plus 3. That's my simplified numerator. Now I still have to divide that by the 1 over x. So now this can be brought on over, and it's just 1 over x. So now I'll do the division. Green divided by white. So negative 3 over x times x plus 3 divided by 1 over x. Keep, flip, change it. So the green will stay the same. I'm going to rewrite it in black here so it shows up. Plus 3. Change it to multiplication and flip the white one upside down. Look for things to simplify. The only thing that simplifies is the x. So final answer, negative 3 over x plus 3. And that is it for the notes on the complex fractions. So if it's better for you, instead of, so like on this one, once I did this numerator, let me go over here and write it. So once I found the common denominator, it was x over x times x plus 3 minus 1 times x plus 3 over x plus 3. You following so far? So now, if you want to flip change this, when you distribute this, you're distributing a -1. Because you got to remember to subtract both terms, not just the x. So then that's why I put it in here like this. Does that make sense? And then now you can divide that with the denominator.